Hi viewers, this is Sri Ramulu. So today's topic is a feedback concept. When a part or fraction of output is combined to the input is called feedback. Right? A part or a small things from output to input. If we give the from output to part of a signal or a part of anything to the input, that is called feedback. If the net effect of the feedback is to increase the magnitude of, here it is not OD, magnitude of input signal, it is called as positive feedback. If net effect of the feedback is to increase the magnitude of input signal, it is called, okay. Suppose what you are getting from output to the input, then if input signal increases, that is called positive feedback. If input signal decreases when we add part of output to the input, that is called negative feedback. See here, if the net effect of feedback is to reduce means decrease the magnitude, so which decrease the magnitude of input signal, it is called as negative feedback. Right? When we when we add the part of output to the input, then to the input signal, if it increases because of adding this, that is called positive feedback. Right? If it decreases the input signal, reduces the input signal, that is called negative feedback. Okay, like this positive feedback. And so that means output part of output can it may increase the input signal or it may decrease the input signal. If it increases, positive feedback. If it decreases, negative feedback. Okay, the general theory of feedback can be understood with the help of block diagram shown in figure. See, this is a block diagram, right? So once I can check it about block diagram. This block diagram contains amplifier with gain, and it is a feedback circuit. Here output, input. See, from output to input connections are given through the feedback circuit. Right? So this circuit can take part of output and it can give to the part to the input. So input signal is Vs. To this we will add here Vf to it. Then it becomes Vi. So that is also given in the diagram. So see in the derivation. The feedback amplifier has two parts. See, this feedback amplifier has two parts. One is what? See, amplifier and feedback circuit. So it is amplifier, it is feedback circuit. The feedback circuit usually consists of resistors. This returns a fraction of the output voltage back to the input. Right? The feedback circuit usually consists, what it consists, feedback circuit means this one consists resistors. So generally it contains resistor. This returns a fraction. So this resistor can give the fraction, returns a fraction of output voltage back to the input. So this resistor, these resistors can make part of output can give to the input. Let A be the gain of the amplifier. That is, gain of amplifier means that is the ratio of output voltage VO to input voltage VI. So that means amplifier gain can be written as A is equals to VO by VI. See, ratio of output voltage to input voltage, output voltage to input voltage, it is called amplifier gain. This the gain of amplifier without feedback, which is, so what I have written A, it is without feedback. The feedback network extract means takes voltage Vf is equals to beta V naught. So beta is a feedback ratio, it is written as Vf by V out. Beta can be defined as feedback voltage to output voltage. The ratio of feedback voltage to output voltage is called beta. Right? Feedback network extract the voltage. How much it extract? Vf from output is equals to beta V naught from the output V naught of the amplifier. So here from this part, how much it extract, this much of it extract. This voltage is added if it is positive feedback. This voltage is subtracted if it is negative feedback. Okay, addition can give a positive feedback, and reduction or subtraction can give the negative feedback from the signal voltage. So here, if you add to the signal voltage, positive feedback. If you subtract from the signal voltage, negative feedback. See here, that is in terms of formula. So input voltage is combination of signal voltage and feedback voltage. If it is added, positive. If it is subtracted, negative feedback. And we have formula also given here. See here. So beta V naught. So that is also substituted here, beta V naught. Okay, equation 1, equation 2 like this. The quantity beta Vf by Vy is called feedback ratio or feedback. Here feed, it is not fed. Feedback fraction. Feedback ratio or feedback fraction. Let AF be the overall gain of the amplifier. This is defined as the ratio of output voltage V0 to applied signal voltage. So what we apply here, we are applying the signal voltage. See, so we are applying this one. Okay, so this is the input signal. It is a Vy is output voltage. Right, AF is what? It is a gain with a feedback. Gain without feedback is a we know, that is a VO by VI. Next, from equation 1, see what is, okay, from this equation we can write VO is equals to like this. Let it is equation 3, and see equation 1 for positive feedback. Let me take for positive feedback. From equation 1, what VI formula is this one. Substitute in the place of VI. Yes, substituted. Okay, and substitute this is in the equation 3. So from equation 1 is what? It is equation 1, right? From equation 1, substitute this equation here. Okay, so then what we get? Oh, we get this one. Multiply a value inside. Multiply a value inside. It is multiplied with this one and multiplied with this also. Okay, so here this side we have this here VO. So bring this is this side. So it becomes negative. Here negative. Take outside common factor, that is a VO or V0. Then becomes 1 minus A beta is equals to ABS only. Okay, and I keep A this side and bring VS this side, and this is this side. Okay, so keep this side VO and this side A. So now this bring this bracket this side and VS this side. Then what it will do? It divides this side and is also divide this side. So then we get VO by VS as a way A by 1 minus A beta. So this is a formula. But gain with feedback is AF. It is defined as output voltage to input signal voltage. Output voltage to input signal voltage. That is AF is equals to VO by VS. And from the equation 4 and 5, see both are same. Right, so we can substitute here. Then AF is equals to A by 1 minus A beta. Right, 1 minus A beta. So it is for positive feedback. So we have derived the equation for positive feedback only. If it is negative feedback, then plus is replaced, minus is replaced by plus only. So AF is equals to A by 1 plus A beta is for negative feedback. It is for positive feedback. Okay. Considering the case of positive feedback, if A beta is equals to 1, that means the place of A beta, if we substitute 1, then AF what happens? AF becomes infinity. Why? A by 1 minus 1 becomes A by 0. Something by 0 is always infinity. So that is why AF is infinity. So this is possible only when input signal is 0. When a beta is equals to 1, when input signal is 0, then only it possible. This amplifier is then capable of producing output even when input is 0. Okay, so it produces output. So that means the amplifier can produce output even though there is no input. Under this situation, amplifier works as oscillator. So under this situation, that amplifier can act as oscillator. The condition A beta is equals to 1 is called as Barkhoudsen condition for oscillator. What is this condition? A beta is equals to 1 is called Barkhoudsen condition for oscillations. Sometimes it is also called as Barkhoudsen criteria also. Not only condition, also criteria. Some people will speak it as a criteria. Okay friends, thank you.